Hello, my name is James Boro, presenting a concept on manual test case generation from activity diagram. The purpose of this session is to enable the subjects or the participants to be able to generate or extract test case from an activity model. A test case simply means a triplet of ISO, where I is the data input to the system, well, S is the state of the system, to which data is the input, and O is the expected output obtained from the system. Test case can be either generated from the source code or from a visual software model, such as the UML, entity relationship diagram, ERD, flowcharts, and data flow diagrams, that is DFDs. In this session, we are going to learn on how to extract test case from a UML activity model of a system, whereby a particular variable is compared with its input value, and then test case is generated to certify the condition. Then the same test input is incremented by 1, then the condition is evaluated, and test case is generated to certify the condition. And finally, the same input is decremented by 1, and the condition is evaluated, and test case is generated to certify the condition. This process is repeated until the last condition is evaluated. To cover both the true and false condition of if statements, a particular relational operator will be combined with its opposite operator, that is greater than and less than or equal to is the first scenario. Then the second scenario is the reverse of this, that is less than or equal to and greater than is the second scenario. Then the third scenario will be less than and greater than or equal to as that scenario. Then we have the greater than or equal to and less than as the fourth scenario. Then the fifth scenario will have equals and not equals, and the last scenario is not equal and equal. The algorithm will cover all the scenario to achieve 100% decision coverage. To explain the above scenario, suppose you have a system to capture or to create a password. The first condition, number of cal is less than or equal to 8, and the expected output is password too short, enter more than 8 characters. Then the second condition, number of cal is greater than 8, the expected output is confirm password. The question is, how will our output look like? That is the test case design. The test case design will have 5 elements, that is the test case ID, which will keep track of the test case evaluated. The second one will be the test condition, which is the variable or the left operand. Then we have the input, which is the value or the right operand. Then we have the expected output, which will hold the information on the data that have been generated if the condition evaluated true. Then we have the test case status, which will hold the result after testing a variable. The algorithm begins by transversing on the decision node. If the first condition of the predicate is number of cal less than or equal to 8, the test case ID is incremented by 1, and 8 is assigned to the input variable, and number of cal assigned to the test condition. Then 8 is compared with the first condition. 8 is less than 8, that is true, hence pass. And the output is the password too short. Enter 8 characters. Then the algorithm increment test case ID by 1 and input value by 1, that is 9, and number of cal is assigned to the test condition. 9 is compared to the first with the first condition. 9 is less than 8, that is false. The algorithm transfers to the second condition, whereby 9 is greater than 8, which is true, hence pass, and confirm password is generated as the expected output. Confirm password. Then the algorithm continue and increment test case ID by 1, that is make it 3, and input value is decremented by 1, that is 7, and number of cal is assigned to the test condition, and this value, that is 7, is compared with the first condition, that is 7 is less than 8, that is true, and this statement, that is password too short, enter more than 8 character is executed. Password is too short. Enter 8 characters. That was the first scenario. The second scenario will produce the same result because it is the reverse of the first scenario. Let's attempt the third scenario. On the diagram, number of cars is the first condition, number of cars is less than 8. The second condition, number of cars is greater than or equal to 8. Let's generate test case for this. The test case ID is incremented by 1, and number of input is 8. Is assigned to input variable. Number of cal is assigned to the test condition. Then 8 is compared with the first condition. 8 is less than 8. That is false. The algorithm transfer to the second condition. 8 is greater than 8. That is true, hence pass. And confirm password is generated. Password is generated. The algorithm continue by incrementing the test case ID by 1, make it 2. Then the input variable is incremented by 1, that is 9, and number of cal assigned to the test condition. 9 is compared with the first predicate. 9 is less than 8, that is false. Then transfer to the second condition. 9 is greater than 8, that is true, pass, and confirm password. Output is generated. The algorithm continue by incrementing the test case ID by 1, that makes it 3. Then input variable is decremented by 1, that makes it 7, and number of cal assigned to the test condition, and 7 is compared with the first condition. 7 is less than 8, that is true, hence pass, and password too short, statement is executed. Sorry, password too short. Enter 8 or more characters. 8 or more characters. That is the third scenario. The fourth scenario is the reverse of the third scenario. So you may attempt this and you're going to get the same results. Let's attempt the fifth scenario. The first condition, number of cal is equal to 8, and the second condition, number of cal not equal to 8. Let's generate output of this scenario. Let's do it together. The test case ID is incremented by 1. Number of cal equal to 8. 8 is assigned to the input variable, and number of cal is assigned to the test condition. 8 is compared with the first condition. 8 is equal to 8, that is pass. And the statement confirm password is generated. Confirm password. The algorithm continue by incrementing the test case ID by 1 to make it 2. The input variable is incremented by 1, that is 9, and the number of cal is assigned to the test condition. 9 is compared to the first predicate. 9 is equal to 8, that is false. The algorithm transfer to the second condition, where is compared with 9 is not equal to 8, that is pass. And the statement password two shots, enter 8 characters. The algorithm continue, whereby test case ID is incremented by 1, that is 3, and the test input is decremented by 1, that is 7, and number of cal is assigned to the test condition. 7 is compared to the first condition. 7 is equal to 8, that is false. And then algorithm transfer to the second condition. 7 is not equal to 8, that is pass. And password two shots, enter 8 characters is generated. Password two shots, enter 8 characters. That is the fifth scenario. The sixth scenario, you may attempt it, and it is just the reverse of the fifth scenario. Let us summarize what you have done with a user login system model. Remember, as a subject or participant, you'll be provided with a model and also a test case template whereby you are going to document your test case. So the algorithm will begin by traversing the first decision node and finds the number of attempts less than or equal to 3. 3 is assigned to the input variable, and number of attempts is assigned to the test condition, and it is compared with the first predicate. 3 is less than or equal to 3, and add transaction output is generated, and test case status is pass. Then the test case ID is incremented by 1, that is 2. The input variable is incremented by 1, that is 4. 4 is less than or equal to 3, that is false. The algorithm transfer to the second condition. 4 is greater than 3, and that's true, that is pass. And the invalid login register output is generated. Then the test case ID is incremented by 1 again, that's make 3. Then the test input variable is decremented by 1, that is 2. 2 is compared with the first condition. 2 is less than or equal to 3, that is true. Add transaction statement is generated, and the test case ID continue is incremented by 1, that is 4, and the algorithm transfer to the second decision node, whereby it finds the first predicate is number of cal less than 8. 8 is assigned to the input variable, and number of cal is assigned to the test condition. 8 is compared with the first condition. 8 is less than 8, that is false. The algorithm transfer to the second condition. 8 is greater than or equal to 8, that is pass, and enter P statement is generated. The algorithm continue by incrementing the test case ID by 1, that is 5. Then the input variable is incremented by 1, that is 9. Then 9 is compared with the first condition. 9 is less than 8, that is false. Then the algorithm transfer to the second condition. 9 is greater than 8, that is pass, and the enter pin output is generated. Then the algorithm continue by incrementing the test case ID by 1, that is 6, and the input variable is decremented by 1, that is 7. Number of cal is assigned as the test codation. Then 7 is compared with the first codation. 7 is less than 8, that is true, and enter 8 or more characters is generated as expected output. The algorithm continue by incrementing the test case ID by 1, making it 7, and then transfer to the third decision node, whereby the first predicate digit is equal to 5. 5 is assigned to the input variable, and digit is assigned to the test codation. 5 is compared with the first codation. 5 is equal to 5. That is pass, and the click submit output is generated. Then the algorithm continue by incrementing the test case ID by 1, making it 8, and the input is incremented by 1, making it 6, and digit is assigned to the test codation. 6 is compared to the first codation. 6 is equal to 5, that is false. Then it is compared to the second codation. 6 is not equal to 5, that is pass, and enter 5 digit is executed or generated as the expected output. The algorithm continue by incrementing the test case ID by 1, making it 9. Then the input variable is decremented by 1, making it 4, and the digit is assigned to the test codation. The 4 is compared with the first codation. 4 is equal to 5, that is false. Then the algorithm transfer to the second codation, where 4 is compared with the same predicate. 4 is not equal to 5, that is pass, and enter 5 digit statement is executed as the expected output.